Hi friends, welcome to the new video where we will be talking about interstitial solid solutions and intermetallic compounds. So just touching upon few things what we were discussing in the last video, we were talking about different types of alloys or the different forms of alloys for that matter. The first category or the first form of the alloys were solid solutions. Solid solution means even after adding the solute into the system, the crystal structure of the solvent is maintained. So that's a solid solution. The other category is intermetallic compounds that we will talk about in a minute. And in the solid solution category, it can be further classified into interstitial and substitutional. We already talked about substitutional forms of substitutional solid solutions, where brass was an example. Now we will go ahead and have a look at interstitial solid solution. So in interstitial solid solution, as the word indicates, the solute atom will be so small compared to the solvent atom. Then what happens is something like this. So then what happens, one good example for an interstitial solid solution is iron. Sorry, it's a steel. Steel is an alloy of iron and carbon. So as you can see here carbon atoms are so small compared to the iron atoms, so they can always occupy an interstitial position. They don't have to substitute they can't substitute, first of all they can't substitute the big iron atom. They can only occupy interstitial positions. So these are called interstitial solid solutions. Here also, as we talked about Humer-Rothery conditions which should be satisfied to form a substitutional solid solution, here also we have got certain conditions. Again, as I was saying, they are all pretty much common sense related conditions. So here are those conditions. First one, solvent atom must have more than one valence electron. The next condition is that atomic radius of the solute atom should be less than 59% of the atomic radius of the solvent atom. So that's what I was telling. So if you want your solute atom to occupy an interstitial position, then there should be a considerable difference in the size. So this is all about interstitial solid solution. Finally, let me just briefly talk about intermetallic compounds as well. So intermetallic compounds have this very complex structure. They have a very complex structure. Moreover, they have a definite chemical formula for carbides. Let's say tungsten carbide is a good example for an intermetallic compound. So tungsten carbide has a definite chemical formula, but steel don't have a specific chemical formula. We talked about brass; it doesn't have a definite chemical formula. So they are very hard. These intermetallic compounds are very hard. They are very brittle. They have a very low density, so they find applications in gas turbine industries, like a lot of nitrates. They find a very good application in gas turbine industry for high temperature applications. They have very good oxidation resistance, and moreover in the phase diagram they don't exist as regions. If you look at the phase diagram of magnesium lead, then these compounds will appear as only very small portion of in the phase diagram. They appear as lines in phase diagrams. Uh, so they appear as lines in phase diagram. So this is all very intermetallic compounds. Okay, intermetallic compounds, talking about intermetallic compounds. One more thing to note, that another good example for intermetallic compound is Fe3C, which is cementite, which we will talk about in very detail when we come to iron carbide phase diagram. So this is a brief about intermetallic compounds as well. So that's it. So now finally one more thing before we wind it up, I wanted to sum up whatever we have seen. So we told alloys which start so we were talking about alloys. Then alloys can be classified into solid solution, intermetallic compounds, and this is solid solution. And sometimes they will also appear as two-phase forms. They will also appear as two-phase forms. So what does this two-phase forms means? First of all, okay, let me explain all this in the next video when we talk about phase diagrams and the basics of phase diagram. Thanks a lot.